Good afternoon, everyone. It's Mrs. Meekings, and it's day 3 of our rapid reasoning recall. Apologies for the late share of this. Unfortunately, the video that I did in the classroom yesterday didn't work, so we're going to go back to the PowerPoint, and I'm going to explain the PowerPoint to you looking at day 3. So we had these 3 questions for day 3. Let's start with question 1. Hopefully, we're all getting used to now looking for ones that we know, and we should hopefully spot there that we've got 3/4, which is 0.75. I'm looking now for tenths. I can see some tenths down the right hand side. Looking down the left hand side, what can I convert into tenths? There we go. 80 hundredths. If I divide the numerator and the denominator by 10, I should end up with 8 tenths. And I could simplify that further to 4/5, but I don't need to, because on the right hand side I can match that with 8 tenths, because there's an 8 in the tenths column. I've got another one here that I can see I can change into tenths, and I'm going to demonstrate that slightly differently. This time I'm going to look at a bar model to show me the 3/5, so I can see that I've got 3 out of 5 coloured in on the top bar, but I want to turn that into tenths. So if I look at the bottom bar, which is in tenths, I can show that the equivalent is 6 tenths. So again, on the right hand side, I should have 6 tenths, and there we go, we've got a match there. I'm left with 35 hundredths and 22 hundredths. I can see them down the right hand side. 35 hundredths matches with 0.35, and remember, we don't say 35 after the decimal point, because it's not really 35, it's 3 tenths and then 5 hundredths, so we say 0.35. And then the last one, I've got 22 hundredths, which is 2 tenths and 2 hundredths, which goes to 0.22 on that one. So looking at question 2 now. Tallulah is thinking of a number. She doubles it, she adds 12, she divides her answer by 4 and subtracts 3. Her answer is 18. And we've got to find out what number Tallulah was thinking of to start with. Now, if you're given an answer and you want to know what the missing number was, you need to do the inverse. But because we've got 4 operations here, we need to do them in the reverse order. So I'm just going to look at each one in turn. She ended with 18. She subtracted 3, so we'll do the inverse and add 3. Before that, she divided by 4, so we will multiply by 4. She added 12, so we'll subtract 12. She doubled her answer. That was the first thing she did. So the last thing we will do is halve our answer or divide it by 2. So I'm starting with Tallulah's answer. So she had 18. I'm adding 3. I know if I add 3 to 18, I have 21. The next thing that I need to do is multiply it by 4, because it's the inverse of what she did. This is one that I can multiply by 4 quite easily. Don't need to do a written method. I can do 4 times 20 is 80, and 4 times 1 is 4, so I've got 84. She added 12, so I've got to subtract 12. Again, I don't need a written method here because it doesn't cross a tens boundary. 84 take away 12 will give me 72. She doubled it, that was the first thing she did, so the last thing we need to do is divide it by 2 or halve it. Again, I don't need a written method for this one. The actual number facts are quite easy on these. 70 divided by 2 or halved is 35, and half of 2 is 1. So I've got 35 and 1, which is 36. So my answer is 36, but yep, you've guessed it, I'm going to make you check it. This is the sort of question that it's really important to check them on. So we're going to start like Tallulah did with 36, so I'm going to work up from the bottom. If I have 36 and I double it, I get 72. She then added 12, I get 84. She divided her answer by 4. If this was a more complicated number, I could do a division bracket or another method to help. But I know that 84 divided by 4 is 21. And finally, she subtracted 3. So she got 18. So we've proved that 36 was the number she thought of, because we ended up with 18, the same answer as Tallulah. So for our next question, we have the area of a square given as 100 centimetres squared. The square is split into 5 identical rectangles. What is the perimeter of one of the rectangles? Don't forget your units. I also want to look at the fact that it says they're not to scale, so don't bother getting your ruler out to measure it. This is one where you need to do the calculations. So going back to the first diagram, the area is 100 centimeters squared. Now I know that area is length times width. So I'm looking for a number that when I multiply it by itself, it gives 100. And hopefully you're all shouting the answer at me, because you all know that 10 times 10 is 100. So the length of each of the sides is 10 centimeters on that square. So it's split into 5 identical rectangles. We want the perimeter of one of them. So I'm going to look at the top one. Now I can put some measurements on there already because I know the two lengths are 10 centimeters. And it also tells me that the length down the side of the square is 10 centimeters. It's divided into 5 equal parts. So each of those will be 2. And obviously I've got a 2 for the other width as well on the other side. Now this is where you could do all of this workings out, but then not get the marks because you mix your perimeter and area. Remember, we want to find the perimeter of one of the rectangles. Now the way I'm going to do this is count round and add them up. So I've got 10, add 2, add 10, add 2. You may do 10 add 10 and 2 add 2, or you may add the length and the width and double it, but hopefully we've all got the same answer, which is 24. But it says finally, don't forget your units. Now it's a length because it's perimeter, so it's not centimeters squared. The perimeter is 24 centimeters, which should be the answer in your box. So a challenge for today. What I want to do for the challenge for today is direct you back to what Miss Addison has put as this week's challenge for Year 6. So on the Year 6 page of our website, Home Learning, the challenge says to explain using a video, hopefully a lot better than I do, you're probably more technologically advanced than I am, a maths concept to Year 3, 4 or 5, or even to your Year 6 peer group. It's up to you who you decide to actually explain your maths concept to. Miss Addison's put an example of her explaining one on the PowerPoint, and she's also put some examples of what you might want to explain to other children. So please have a go at doing that. Share them with us. You can share them on Twitter if they're short enough, or your parents could email them to your class teacher's email address. So we look forward to seeing all of those soon. And I'll see you tomorrow for day 4's answers.